Alright YouTube, what is good? It's your boy Rebel back with another video, and today we are taking a look at PiD. Now PiD is essentially fast and high resolution latent decoding with pixel diffusion. So PiD directly decodes latent representations into high resolution images, replacing the decode then super resolve cascade while achieving lower latency and higher visual quality. So most practical high-resolution text-to-image systems rely on latent diffusion models where generation is performed in a compact latent space and a decoder maps latent back to pixels. Yet, the latent to pixel decoder is reconstruction-oriented, optimized to invert the encoder rather than synthesize more details, and becomes increasingly costly at a megapixel scale. Using PiD, which stands for Pixel Diffusion Decoder, reformulates latent decoding as conditional pixel diffusion, unifying decoding and upsampling into one generative module. By denoising directly in high-resolution pixel space, PiD synthesizes 4x and even 8x upscaled images with low latency. For latent conditioning, a latent sigma-aware adapter injects noise-corrupted latents into the pixel diffusion backbone, enabling PiD to decode partially denoised latents and terminate the latent diffusion process early. So essentially, you're decoding latents of 512 by 512 into 2048 by 2048 in under 1 second with 13 gigabytes of peak memory on what they consider consumer 5090. Now, the models available right now are Flux 1, Stable Diffusion 3, Z-Image, Flux 2 Dev, and the Dino model. If you would like to know a little bit more about this, I will link the NVIDIA research page in the description so you guys can take a look at it. But the cool thing about this is someone has already introduced a custom node set. I will link the custom nodes in the description so you can install them, as this is all you are going to need, and you just apply it to whatever model you would like to use. As far as the workflow goes, it is actually available in the custom nodes. I also will post a link to a custom workflow in the description if you guys are struggling setting up the GUF format, even though it's just the UNet node that you would need to implement instead of the diffusion model. Here is a custom workflow available for you guys, and it actually contains all of the instructions to install if you get stuck anywhere. So the model I'm going to be using today to take a look at these nodes is going to be Z-Image. The first thing you're going to need to do to get the nodes is you are going to need to navigate to your custom node directory, and you are going to click the address bar and type cmd and hit enter. And that is going to bring up a command prompt in your custom node directory. And then you're going to come back to the workflow link and you're going to copy this git clone link. And then you're going to come back to your command prompt and right click and then hit enter to paste and run the git clone. After you install the custom nodes, you're going to come back to the workflow to this number 6 here, and you're going to copy this command here. And then you're going to come back to your comfy root folder where your bat files are, and you're going to open up another command prompt by typing cmd in the address bar and hitting enter. And then you're going to right click that copied command and hit enter to run your requirements. If you are on desktop, you are simply going to run the pip install -r space requirements.txt. That is your usual desktop requirements install. You type pip install -r requirements.txt and then hit enter, and this will run your requirements on desktop only. After that, you both can X out of your command prompt and you are done with the custom nodes. If you don't have the files for Z-Image Base, I will link my CividAI page for the files in the description as well. But after that, you can grab the workflow from the folder and throw it in Comfy, and it will look something like this. So on the left here, you have your cheat sheet for quality settings. It's pretty self-explanatory. So the only thing you're going to want to remember is these settings here. So if you're generating with the 2K model in the PiD prepare node, you're going to want to generate at 512 by 512, and it will scale your output to 2048 by 2048. If you use the 2K to 4K, you are going to start your generation at 1024 by 1024, and then it will output at 4096 by 4096. Be aware that this is way more computationally heavy. The 2K is going to be your best bet for, low VRAM setups. It's still going to generate at 2K, which is a great output. And then you could just use like the RTX super resolution node if you need. But other than that, I would probably use a GUF if you're going to do anything. Starting on the left here, we have a load diffusion model, we have a load clip, and a load VAE running your usual Z image based setup. Here we have our PID text prompt. Now with this node, you're going to want to input a very depthy prompt, meaning you want a lot of detail and description. The reason being, now that you are generating in a latent pixel space, you have a lot more control and prompt adherence. So you're going to want to feed it as much information as possible to provide your best output. You'll notice that the example prompt is 3 separate paragraphs, and that is because it's going to give you a really good clean output and it's going to adhere almost perfectly. Now, the only thing I did differently was I moved a tiled VAE decode because I was getting some errors on the 2K to 4K model. But other than that, you should be able to run this 50 steps, no problem. If you usually run a Z image base workflow, you can use the GUF, like I said, if you need to. It will be, a lot less compute. Just keep in mind that this cheat sheet is here on the left if you forget any of your setting values. So to touch up on this prepare node a little bit more, so here is your backbone, which lists all of the models available to use with this custom node setup. Right here is your checkpoint type, which is going to be 2K to 4K, and this auto downloads it, by the way. Right down here, you have an auto download section, which that way you don't have to go to Hugging Face and actually download each model individually. It will handle it for you based on the backbone you choose and checkpoint type. And then down here you have cleanup after prepare, which just, flushes the entire pipeline backside. Now right here is your PID sampler. So this is just going to run an extra 4 steps, I believe. And you have your finalizing node that runs over here. So this, just consider this like your refinement section. And then on the end here, it has 2 different save image nodes. And this is just so you can compare the decoded image to the PID image. Now, the first time you run this model, either way, like if you run the 2K or the 4K, it's going to have to download the source directory. So you may have like a longer gen time on the first generation with these 2 nodes having to download and install your checkpoint type. But with that being said, that accounts for the workflow. So I do have some examples and we will be taking a look at those now.
But to save time, instead of showing you example by example, I'm just going to fire off the Z image base generation and then the PID generation next to it on the right. So on the left, you will see Z image, and on the right, you will see the PID generation. All right, guys, that's all I'm going to have for you today. Just wanted to get this workflow and this custom node set to you guys because I feel that most models are going to start leaning towards this pixel latent diffusion space. So having Z image base available in latent pixel space is amazing because this is arguably the best open source model we have right now. And the fact that we can get some, really high fidelity images in pixel space is crucial for the lifetime of this model. But if you enjoyed what you saw today, please consider subscribing to the channel and leaving me a comment on the video to let me know how I did. You can also like the video. It genuinely helps the channel tremendously. So go ahead and download this workflow, get this custom node running, and enjoy Pixel Space Z image. All right, guys, thank you. Have a nice day. Bye.